Equilibrant and resultant. Let's see the difference between equilibrant and resultant. I want to use diagram to explain this so that it will be clear, to avoid ambiguity. Let's say this is a pail of water. A pail of water. Now, let's say this pail of water is being carried by a man from here with a force F1. Let's say this is the hand of the first man, and then this is the hand of the second man. Both of them, they apply the force F1 and F2. They want to lift the pail up. You will notice that if these two men drag it from this side to this side, so if they both drag it, the pail will go up because they want to lift it up. So that means there is a force that is acting along, that is taking it up, because the two men, no matter where the direction is coming, since their intention is to lift it up, so no matter how their hand is, they will still lift this up. So that means the overall effect of these two forces is to pull this pail up. That means this single force that indicates the direction where the pail is going is called the resultant. That is the result of these two forces, what they produce, what these two forces, what they produce, the effect that they produce on this bucket is to drag it up. So that means if I complete this diagram, I can imaginarily draw a line to meet with this at this point. This is the point of effect of the two forces, and there is an angle between them. So there is an angle between the two forces. So that means the resultant is coming from this point of action. So the resultant is a single force that is obtained when two or more forces are compounded together, when two or more forces are added together factorially. So these two forces, they produce an effect of dragging this bucket up. So this force that indicates the single effect of these two forces is called the resultant. Now, one thing about resultant is that it can stand alone. The same effect that these two forces have on this bucket is what we will have if a single man is dragging it up and stay and drag it to this direction. So it's the same thing that we are going to have. Now, that is what they call resultant. How do we now know an equilibrant? So if you don't want this bucket to go anywhere, we want this two man to drag it, and still we don't want it to move. So then we must have a force that will act downward, such that as these two men are dragging it up, this single man will drag it down so that this will not move to anywhere. This single force that is dragging it back, that makes this to stay one place without moving to anywhere, is called equilibrant. So you can see that we cannot have equilibrium without having the two or more forces that are acting. So equilibrium cannot work unless we have some forces that have already come. But that means equilibrant is a single force that balances two or more forces. That's the difference between resultant and equilibrium. Resultant is a single force that is obtained when two or more forces are compounded together, while equilibrant is a force that balances two or more forces. Now, what is the similarity between them? The similarity between resultant and equilibrant is that both resultant and equilibrant, they have the same magnitude. I can draw the diagram better. Let me redraw the diagram so that we can understand better. So to have more physics concepts inside. If this is the first force and this is the second force, let's say this is F1 and this is F2, there is an angle between them. So let's call this angle theta. So if we want to get the resultant of these two forces, we must complete the parallelogram. Let's complete the parallelogram. So the resultant will come like this. So this is resultant, R. So this resultant is the single force that has the same effect as these two forces. Now, what is now equilibrant? Equilibrant goes down like this, just as I explained in the diagram. Now, the similarity between resultant and equilibrant is that resultant is also equal to equilibrant. They have the same magnitude, but their direction is different. So, anytime question asks for resultant and also asks for equilibrant, just find resultant. It's easy to find the resultant. Then you just equate both of them together. They are the same, but just change their direction. You can see that this one is going upward and this one is coming downward. Similarly, if we have the diagram like this, if you have the diagram like this, just like this is F1 and this is F2. Resultant we go by completing this parallelogram. Resultant we go like this, and equilibrant we go down like this. So both must have the same effect. That's just the simple difference between resultant and equilibrant. Thank you for viewing. God bless you.